Many of our problems this semester will be able to be solved very quickly using conversion factors, which is a basic strategy for unit conversion. Conversion factors are all based on identities. For example, if we look at the identity that 3 feet is equivalent to a yard, we can write two separate conversion factors in which equivalent quantities are written in both the top and the bottom. And since each of these quantities is equivalent, numerically it's equal to 1, and therefore multiplying by this factor is not going to change the meaning of our number. So we can multiply our number by a conversion factor to achieve a number in our desired units. Let's look at this introductory problem. We want to know how many feet there are in 3 yards. Now, immediately we can do this in our head, and we know that the answer is going to be 9 feet. But how did we know that we needed to multiply by 3 rather than divide by 3? And we're going to formalize our steps to answer this question so that you can do the same process when the answer is not quite as obvious. We start with our identity that 1 yard is equivalent to 3 feet. So with that identity, we can write two different conversion factors. We know that 3 feet divided by a yard is equal to 1, and that's because these are physically equivalent lengths. A yard is equal to 3 feet, and this ratio is also equal to. Now, to start, we'll write down our initial number with its unit, 3 yards, and we choose the conversion factor that we will need in order to cancel out units of yards, which is our first one here. Yards divided by yards is equal to 1. The same way that 3 over 3 is going to cancel out to be numerically equal to 1, a yard divided by a yard is equal to 1. So we write our conversion factor, 3 yards times our conversion factor that a yard is equivalent to 3 feet. And this way, we know that yards is going to cancel. We have yards in the numerator here and the denominator over here. Now that we know that we have our desired units and the answer, we can do the math, which is 3 times 3. It comes out to 9 feet. So writing our units out in the form of a conversion factor will allow us to know that we need to multiply by 3 rather than divide by 3. We're going to do the same process going through these metric to metric conversions. In this first problem, we're converting between milliliters and liters. So I'll remind myself that 1,000 milliliters is equivalent to a liter. I prefer to use this identity rather than a milliliter is equal to 1 times 10 to the minus 3 liters, simply because the numbers are much easier to work with, and I suggest you do the same. With this identity, we can write our two conversion factors. 1,000 milliliters is equal to a liter, and we know that a liter is equivalent to 1,000 milliliters. Our initial number is 96.4 milliliters. Include the number with the unit so that we can choose our conversion factor. We know we need to cancel out units of milliliters, so we want to use the conversion factor that has milliliters in the denominator. So we know a liter is equivalent to 1,000 milliliters. That means for this conversion we need to divide by 1,000, which we can do in our calculator, or we can simply move our decimal point 3 spaces. So our answer is 0.0964 liters. In our next problem, we're going from liters to milliliters. It's going to use the same two possible conversion factors, that 1,000 milliliters is equivalent to a liter, and a liter is equivalent to 1,000 milliliters. We'll write down our initial number, 0.044 liters, and we're going to multiply it by a conversion factor. We choose the conversion factor that's going to give us the units that we want, which is milliliters, and so therefore we have to cancel out units of liters. So a liter is equivalent to 1,000 milliliters. Now we know we need to multiply by 1,000, and our calculator answer is going to be 44 milliliters. Here we see the utility of the metric system, because the same relationship holds between grams and milligrams as holds between milliliters and liters, and that is that 1,000 milligrams is equal to a gram. So we can write our two conversion factors with equivalent quantities on both the top and the bottom. And we can multiply our initial number by the correct conversion factor, and we know our answer is numerically, physically unchanged. So again, we write down our initial number that we're given, plus its unit. We know that we're going to use the conversion factor that has milligrams in the denominator. 1,000 milligrams is equivalent to a gram, so we know we need to divide by our 1,000, and our calculator answer is 0.361 grams. The relationship between centimeters and meters is that 100 centimeters is equivalent to a meter. So we can write two conversion factors. Our initial number is 475 centimeters. We choose the conversion factor that's going to cancel out units of centimeters and give us units of meters. And we see here that we're going to have to divide by 100, so we move the decimal point twice to a smaller number, 4.75. I'm sure it feels very tedious at this point to continue to write out the identity and both conversion factors, but I encourage you to do that until you're very comfortable solving problems this way. Grams and kilograms, we know that 1,000 grams is equivalent to a kilogram. So we have our two factors. We can choose which one to use by writing down our initial number with its unit and noting the units that need to be canceled. Here we see we have to cancel grams. So we know 1,000 grams has to be in the denominator. The numerator is kilograms. Grams cancel, so we divide by 1,000. 1,000 is in the denominator. That indicates division. So we have 0.711 grams. And finally, meters to millimeters. We know that there's 1,000 millimeters in a meter. We write our initial number down. We want to use the conversion factor with meters in the denominator. So a meter is equivalent to 1,000 millimeters. We know units of meters cancel out. That indicates we multiply by 1,000, and our answer is 8.34 millimeters. Now we have some density problems. Density is given by mass divided by unit volume, and it's a characteristic property of matter, meaning it varies from substance to substance. Typical units are grams per cubic centimeter or grams per milliliter, and remember, these are exactly the same. They're set by definition, so these units can be used interchangeably. Grams per cubic centimeter or grams per milliliter is typically used for liquids and solids. Gases are more conveniently expressed in grams per liter because they're much less dense. So we're going to practice using density as conversion factors. For example, if we knew that the density of olive oil was given as 10.49 grams per cubic centimeter, we can use this identity to write two conversion factors. 0.92 grams is equivalent to a cubic centimeter, and a cubic centimeter is equivalent to 0.92 grams of olive oil. So in this initial problem, we have 38 grams of olive oil, and we want to do a conversion to know how many milliliters that is. So we are going to use our density as a conversion factor. We know that 0.92 grams is equivalent to a milliliter, and that a milliliter is equivalent to 0.92 grams. Okay, and note the 0.92 number stays associated with grams. So by inspection, we see that we want to cancel out units of grams and have units of milliliters. So we write that 0.92 grams is equivalent to a milliliter. This allows us to cancel units of grams, and the unit that survives is milliliters. To get our answer, we divide 38 by 0.92. 0.92 is in the denominator, and that indicates division. When we put those numbers in our calculator, we get an answer of 41.3043. And we're going to use two significant figures in our answer because there's two sig figs in both of these numbers going into our answer. So our final answer is 41 milliliters. In this second problem, we're also going to use density as a conversion factor. However, in this case, our density is different because we're talking about a different substance. Our identity is that 0.789 grams is equivalent to a milliliter. So we can write two conversion factors. And again, note that the 0.789 number stays associated with grams. So we start with the number that we're given with its unit, 225 milliliters, and we know we need to multiply by a conversion factor to get units of grams. So we want to use the unit, or we want to use the conversion factor that has units of milliliters in the denominator. A milliliter is equivalent to 0.789 grams, and we do the math of 0.789 times 225, and we would get the number 177.525 grams. In this case, we're going to use 3 sig figs in our answer because there's 3 sig figs here, 3 sig figs here, and our final answer is 178, since this first number to be dropped is 5, so we're going to round up, and our unit is grams.